Welcome you all. Dear Excellency, British Ambassador Jill Gallard, it's so nice to have you here with us. It's so nice to have another strong woman with us. Welcome at the Technische University Berlin. And there's another strong woman with us. This is our State Secretary, Armaghan Naghipour. Also very nice to have you with us and to be together to this very important topic we will have today at our famous Queen's lecture. And I'm really looking forward to the lecture and to the talk, because I think this is one of the most famous and the most important topics we have in our day. This is about mobility, and we will learn about this soon more. But welcome you, Sarah Sharples. Very nice to have you here, and very nice to have you in this strong circle of women. So welcome you all, guests, students, and dear ladies and gentlemen. I see that you all have found the way to come here, and this is maybe the first important question. How did you get here? Did you get here by just walking, or did you take the open traffic, or did you maybe come per bicycle? Traveling is something we need to meet and to communicate, so it's something which forms us, our idea of being human, and also our idea of meeting. But traveling is also a problem forming our planet. So it is really time that we think about new ways of traveling, that we really take the time to think about how we travel, what we do when traveling, and how we can do it in a way that is good for human beings, but also in a way that is good for our climate and for all of us and all our world. Most of the time, we only think about if we can reach a goal in about 1 hour or less, and we are already quite uncomfortable if we miss a train or if we are in a rush hour, and this really forms our everyday lives. So we should think about traveling also as a journey, and the journey is also something we can really appreciate, and where we can meet people, or where we can do things which form our lives and which form our communication. So this is an experience that you can enjoy when you make active use of your commute. Autonomous driving is one topic which has an impact here at the Technische Universität Berlin, but which is also an important topic when we talk about future mobility and how we will travel from places to places. We cannot take traveling just for the sake of traveling. Traveling is an important part in the days and in the time we have. Traveling cannot be a consumer product that we take for granted, especially in these days where we have to talk about climate change, about the future of our world. It is important that we also have to think about which kind of traveling we really need, and where we could also say, no, we don't need it. It has to be more about just going to other countries and making some connections. We really have to feel that we are one world, that we belong together. And of course, traveling is also a very positive thing to come together. Just some minutes ago, we already said that it is not taken for granted that we can again meet in presence. And I really think that we should appreciate that we can all come together here today and see each other and meet each other and feel each other. And this is also has something to do that with communication, with human beings, and also with traveling. I think most of you have come from Berlin, but of course traveling does not focus only on mobility in large cities or in the regional context, but also like traveling around the world and the things of transportations we have for longer distances. Technical innovation No matter how climate friendly and environmental friendly, only ultimately benefits if we review and redefine our basic understanding of mobility. We need ideas to make it possible for more people to be mobile using just one vehicle. So if everybody is just centered on his own mobility, this will not be a future for us and our world. Greater importance has to be given to the experience of mobility than to the mere possession of mobility assets. Social change has no reset button. And we really have to reflect before we act. This is why we have to rethink mobility. And you know, rethinking does not just mean that we think everyone for his own, but also that we are doing some research on it. And I do know that we have the perfect woman today with us who will talk about this topic, and I'm really, really delighted because I really think mobility and this focuses so many aspects of our life. What is clear is that people need mobility. People need communication and people need to meet each other. We all remember the world in the last 3 years where we basically all meet virtually. And I strongly believe that meeting only virtually or in digital worlds does not bring us together and does not allow us to stand together as we need it in the crisis day today. So it's very important that we stand together, that we come together, and that we talk together about the crisis we have to face in the next decades. And therefore, it is important that we meet and that we can trust each other. Who's better to initiate a dialogue on mobility than Sarah Sharples? She's the Chief Scientific Advisor for the United Kingdom's Department for Transport, and she's Professor of Human Factors in the Faculty of Engineering at the University of Nottingham. Dear Sarah, welcome to the Technische University, sorry, this was English, to the Technische Universität Berlin. Thank you very much for joining us, for coming to Berlin, and for taking the traveling. And also, of course, I would like to thank everybody who was organizing and making this event possible. Thank you very much to the British Embassy. For me, it's the first time to be here in the Queen's Lecture, but I can say that it's a very special moment to have you with me. Be my guests. Very nice to have you here. And I'm very happy now to hand over to our British Ambassador. Please come to the stage.
Vielen Dank, Geraldine. Ich freue mich, dass wir endlich wieder eine Queen's Lecture in der TU Berlin als Präsenzveranstaltung durchführen können und begrüße Sie ganz herzlich hierzu. But I'm now going to switch into English, which you will be relieved to hear is better than my German. And to answer your question, Geraldine, I came here by electric vehicle this afternoon, so I'm trying to lead by example in the British Embassy. I do just want to spend a couple of minutes on history, if you will forgive me, because it's particularly poignant to me that this is the first Queen's Lecture we've done in Berlin since Her Majesty died nearly 2 months ago. And for me personally, I met Her Majesty several times. My job title was Her Majesty's Ambassador, and I am now His Majesty's Ambassador. And so to someone like me, who's a British diplomat, it's wonderful to be posted in a country like Germany, which has such strong links to the British royal family. And I loved that photo that you had of the Queen up there when we came in. I think this lecture series is a really fitting tribute to her. And if I may just take the opportunity to thank not just the people of Berlin, but all around Germany who sent messages of support and condolence when the Queen died. We had 3,000 people come to the embassy alone to sign the condolence book, and that included current government figures, past government figures, members of the public, people who'd never met the Queen, and some of the messages were fantastic, particularly from younger people. So thank you for that. And a little bit of background to the Queen's lecture, in case there are others here who haven't attended one before. So the Queen visited Germany 5 times. That is the most times she did a state visit to any country other than France, which is equal first. She visited both 5 times on state visits. And in her first visit here, in 1965, Her Majesty created the Queen's Lecture as a kind of legacy to Berlin and to show the importance of the relationship. And actually thinking about mobility, that visit in 1965 shows how things have changed, because Her Majesty spent 10 days in Germany in that visit, and nowadays, of course, politicians and royals quite often spend 24 hours or less, because with modern transport, it's become easier to spend less time. It's a double-edged sword, I would argue. But from the outset, this lecture has always been given by a distinguished British scientist to symbolize the close cooperation between our 2 communities. And the first lecture took place in 1966, when Dennis Hay Wilkinson, who was an experimental physicist studying at Oxford, spoke on European collaboration in science. And the lectures ran every year, apart from a gap in the late 70s to the mid-90s, and they were re-instigated in 1997 to mark the 50th anniversary of the founding of the TU. And I would like to thank Geraldine and the TU for being such wonderful hosts for this lecture every year. A recent highlight in the series was during the Queen's last state visit to Germany 7 years ago, when Neil McGregor was the guest speaker at this lecture. And of course, lots of you here, no doubt, know him. I also want to say that the theme of mobility is really timely for this year's lecture, given that COP27 is happening as we speak. And indeed, both our countries' leaders are meeting each other there today in Sharm el-Sheikh. And we in the UK were really proud to host COP26 last year in Glasgow. Obviously, it's historic that the Climate Pact was signed, but what we need now is implementation, and that is very much the focus this week and next in Egypt. If there are any German government members here this afternoon, I'd like to say thank you for what you've done in your G7 presidency this year to try and keep climate change and sustainability at the top of the global agenda. It's a huge part of what we do in the British Embassy, and I'd like to thank the brilliant team at the British Embassy and the British Council for everything they do to help us with that big agenda. So Sarah, I'm absolutely delighted that you are here today to speak to us. Geraldine has introduced you. What an amazing expert to have. Thank you for making the journey. And I'd also like to say it's the first time I've been on a panel where the other 3 senior speakers are all women. Yay! And without further ado, I'd like to invite the State Secretary to come up and say a few words. Thank you very much, everyone.
Well, thank you so much. And I actually want to say, dear Female Future Force, dear Professor Sarah Sharples, Ambassador Jill Gallard, dear President Geraldine, Rauch, distinguished guests. For me, this is the first Queen's lecture that I'm attending, so thank you for honoring me with your invitation to be with you on this special occasion today. I would, me too, like to begin by offering condolences in the name of the Senate of Berlin for the loss of Queen Elizabeth II. It was her who offered us this annual lecture as a gift, creating a special bond between her and the federal state and the city of Berlin. So from this year on, this lecture will not just be a great opportunity for academic exchange, it will also serve as a reminder of its benefactor. Well, the Queen herself honored us in visiting a special summer edition of the lecture in 2015, together with her husband, Prince Philip. I'm sure that this visit is kept in very good memory at the Technische Universität Berlin. Well, let me return to academic matters and to the future, namely the future of mobility. This lecture's topic, a human-centered future of mobility, could not be more relevant to Berlin as a vibrant, as a growing, as a diverse city. I think we all want our cities to be humane urban landscapes that are sustainable, that are safe, that are easy to navigate for everyone, we've heard it. So mobility in this type of landscape requires inclusive concepts, we've heard about those, a new understanding of public space also, and a strong commitment to diversity. It also obligates us to consider the external effects of our cities, well, to limit our use of depletable resources, and most prominently, of course, to consider the effects of our mobility on our planet's climate. The Senate of Berlin is deeply committed to the transition to a new type of mobility, the famous Verkehrswende. We are working on better public transportation, we're working on more bike paths, we're working on a greener city and more accessible digital solutions for complex traffic problems. We want our city to improve our citizens' safety, our citizens' health, and overall well-being, knowing that this requires work, obviously, dialogue, and at times a fair bit of stamina. The transition we are facing requires all of us, but especially academics and us policymakers, to look beyond mere technical aspects of transport policy, to follow holistic, cooperative, transformative strategies, and sometimes, like in Sarah Sharples' case, to span the length between research on the interested details of human-machine interactions and the no less interested details of providing invaluable scientific counsel to government actors. I know that many scientists in Berlin are committed to research on new types of sustainable mobility, especially here at the Technische Universität, with its, well, I would say, very distinctive academic profile, which focuses on both energy systems, mobility, and sustainable resources, and also on urban and environmental systems. You also educate the next generation of scientists and other creative minds that will shape the face of our government institutions and shape the face of our enterprises in this crucial transitory phase. So your work here, dear all, enriches. It enriches our city's culture with a scientific perspective, from a scientific perspective, and I'm especially grateful for all these many contributions to not only the scientific, but also to our city's social discourse. So as a representative of the state government of the Berlin Senate today, I welcome you today, and I would like to take the opportunity to thank you all for your excellent work. As the Permanent Secretary for Science, for Research, and for Gender Equality, it's the first time that actually these three areas come together in my person and the Senator's person. I want to express the hope that based on your contributions together, we will be able to transform Berlin and other cities into even more inviting and into even more livable spaces. Now, let me wish us all a wonderful, very inspiring afternoon. Like Geraldine Rauch says, it's great that we're coming together, that we're talking and interacting, and I wish us all very interesting and fruitful conversations, and I'm very excited to hear the words of Sarah Sharples now. Thank you so much.
Okay, there she is. We are waiting for her. She is an expert for more than 27 years in a range of technologies and in interaction with people, technologies, and their settings. And not only in research, but also in bringing her research into application and into the real world, which is really important and which we shouldn't miss at the university. She co-edited the 4th edition of the Ergonomics and Human Factors textbook, Evaluation of Human Work, and was president of the Chartered Institute of Ergonomics and Human Factors from 2015 to 16. And she was the Pro-Vice Chancellor for Equality, Diversity and Inclusion and People at the University of Nottingham from 2018 to 2021. So in this very short summary, you see that this is the most interesting woman, and now I have talked a lot. I'm very happy to hear your talk.
Thank you. President, Ambassador, State Secretary, colleagues at the British Council, and all of the guests who've come along today, thank you so much for the honour of the invitation to deliver the Queen's Lecture in 2022. I'm going to talk to you about a human-centred future of mobility, and I hope to make you think about what the future holds and why people need to be at the heart of all of our thinking about mobility. Trains, planes, boats and automobiles, self-driving shuttles, freight delivery drones, hydrogen planes, battery electric vehicles and e-scooters, high-speed rail, connected roads, future fuel systems for airports, port logistics and data to support passenger choice. Technology is delivering a transformative change in transport, unlike anything we've seen for over 100 years, when the introduction of the motor car changed the way that we use our roads. And technology can be seductive, exciting. Its innovation can lead to economic prosperity and growth. Indeed, many countries and cities have been permanently shaped and influenced by the potential and the reality of technology. Since 1991, I've lived in a UK city called Nottingham. Now, you may have heard of Nottingham through its fame as the home of Robin Hood, or perhaps through its football team, Nottingham Forest. But Nottingham was also the place where Ned Ludd, to whom in 1811 the Luddites swore allegiance. The Luddites smashed the new wide-frame knitting machines that could do the jobs of 6 people. But the invention of the knitting frame radically changed Nottingham, bringing economic prosperity to many in the area, evidence of which we still see in the city today. Transport faces many challenges. From the transformative impact to travel patterns that we've seen since COVID-19, to the economic impact of the ongoing cost of living crisis and energy challenges that are affecting many nations in the world, to the international urgency that we see in this week of COP27 as we aim to deliver a target of net zero carbon emissions by 2050. We have a need and an opportunity to change the way that we travel. The future of mobility isn't just about technology. People are at the centre of our transport system. In the introduction, you heard that I'm a professor of human factors. You may or may not have come across the term human factors before. In the UK, the terms human factors and ergonomics are synonymous. And the word ergonomics was coined after, in 1949, a group of men met in the Admiralty in London. They'd identified a gap, not quite physiology, not quite psychology, not quite engineering, where there was a need to establish a discipline, a new discipline, to understand the capabilities and limitations of people in the workplace. One of those men, Howell Murrell, wrote some doodles as they were talking, and you can just see an image of that on the screen in front of you. They came up with a new word, not anthroponomics or bionomics, but ergonomics, derived from the Greek words for law and work. They founded the Human Ergonomics Research Society, and in 2014, this same grouping was granted the Royal Charter by Her Majesty Queen Elizabeth II as the Chartered Institute of Ergonomics and Human Factors. As a discipline, human factors is sometimes described as fitting the task to the person. But my preferred way of thinking about things, the way I try to enthuse people about the importance of embedding human factors into the design of new systems, is to say, humans are fallible and humans are brilliant. Our job is to minimize the impact of human fallibility, but to maximize the value of human brilliance. So what the discipline of human factors gives us is theories of human fallibility and human brilliance. It also gives us methods of how to capture, measure, and understand people's performance and response in a range of different settings. And critically, it requires us to take a whole systems perspective. So what does human factors mean in the context of transport? Transport systems are complex. From the consideration of avoiding disruption to utilities when we construct a new light rail system, to the provision of communication systems to enable real-time information about the movement of people and goods, to dedicated transport control systems, to the personal experience of travel. Whether we are receiving a parcel at home, travelling to work, school, or flying overseas, there are numerous interacting factors that contribute to the individual experience of a single journey. And it's often that perception, how we feel, that affects our choice of how we travel. So how do people fit into this complexity? As I mentioned, systems thinking has always been at the heart of human factors. And many complex systems methods exist. They're often used to describe the causative factors of incidents, or to help us predict what will change when we introduce new technologies. What we see on the screen here is something called the onion model. I find this a really helpful tool that describes the interaction between people and technologies in complex systems. It was originally designed purely to describe work as part of the goal of fitting the task to the person. But I now use it much more to apply to activities such as completing a journey. At the centre are people, with technologies and artifacts, the physical things all around us. I'm here, I'm a person, I have technologies, but I also have artifacts, my paper, my glass of water. This is how we conduct so many tasks with technologies. In the context of travel, this might be the rail passenger, their use of mobile technologies to find information about their journey. And then the fact they're carrying a bag or wearing uncomfortable shoes. These people, in combination with their technologies and their artifacts, complete tasks such as identifying the right platform to be standing on to catch your train. And we're good at measuring those tasks. But we also have goals, a purpose. And that goal might be to get to your destination as quickly as possible. Or it might be that your journey is the only chance in your day to get some exercise. It might be that during the journey, it's really important you're able to complete some work. Or you might be looking forward to the journey to be entertained, to listen to some music or a podcast. These goals, which are much harder to measure, much less visible than tasks, are critical to consider when we're designing a journey. The people, technologies, and artifacts are situated in a local setting, the station platform, their train seat. And this local setting is within a wider context, such as the station or the train. That wider system is influenced by an organisational culture, the legal and regulatory frameworks, such as safety, allocation of responsibility, social expectations and norms. In the UK, Nottingham is towards the north of England, and if you go on the local tram, usually people will be chatting, talking to each other, even if they don't know each other. When I work in London, if I travel in the morning, there is an eerie silence, no matter how many hundreds of people are on the same train carriage. Financial limitations and opportunities also influence that organisational culture, the cost of the journey, the level of subsidy provided by the government, which is very different in the UK compared to Germany. And then technical capabilities, such as whether the Wi-Fi works on the train. Theories of human factors explain that if we get the consideration of all of these elements right, then we have positive outcomes, better design, better system performance, and better culture and behaviour. The discipline of human factors offers us further help through a detailed understanding of those capabilities and limitations of people. Our understanding of physical diversity and capabilities enables us to design to ensure comfort while travelling, and also to accommodate the needs of those with disabilities. Our understanding of cognitive capabilities explains the limitations of human workload, the need to balance between the demand placed upon us and the resources we have available to balance that demand. This diagram illustrates a quite basic theory of workload called the limited resources theory of workload. It shows that how we work hard to maintain good performance, even when the demands that we experience are very close to using all of our available resources. We're usually just not aware of this difference that's happening because those demands are within our capacity. But what we also know from work that we've done observing air traffic controllers is that performance does not, in fact, degrade gracefully. It can result in a sudden loss of ability to maintain task activities and bring associated safety and performance risk. Methods not only help us to identify how many people we might need in a work sitting and how they might work together with technology, they also help us to consider the modality through which we deliver information. The dual task theory, for example, helps us to explain that we're better at coping with two sources of information when one is visual and one is auditory, as opposed to two competing auditory signals or sources of information. And we've known this for many years, and it influences things like the designs of aircraft cockpits. One of those elements of human brilliance is the building and responding to situation awareness. This describes the fact we're not only good at understanding a current complex situation, but we also project the future and use that projection to influence our decisions. It can be a critical characteristic, particularly when we're responding to unexpected events. And it's sometimes described as being in the loop. But also, we recognize that people are social beings. When we're completing an unusual journey, say traveling to a one-off sporting event such as the Olympics, we'll follow information given to us on our mobile device or through physical signage, but we'll also follow the crowd. That crowd is a useful social cue that provides us with confidence and builds trust in the information we're receiving from other sources. So I'm going to talk about three aspects of mobility where I believe we need to be human-centered. I'm going to talk about automation, decarbonisation of transport, and then the end-to-end journey. Let's start with human-centered automation. Automated driving is introducing a step change in the way in which we design and deliver vehicles and infrastructure. Let's think about how people and vehicles work together now. And it's quite remarkable when you think about it, how little the act of driving has changed since the introduction of the motor vehicle to roads in the early 1900s. The human driver is responsible for controlling the movement of the vehicle using a steering wheel and pedals. They've made strategic and tactical decisions about where to drive and how to drive. The vehicle responds. It moves, it provides feedback to inform the driver through other information as well, such as a speedometer. The driver senses, it feels that movement of the vehicle and takes in information from other surrounding resources through their visual, auditory, haptic, and proprior senses, our senses of movement and vibration. Even though there has been continual improvement that has enhanced the quality of control a driver has over their vehicle and the feedback given to the driver, the basic allocation of function between the vehicle and the driver has remained remarkably persistent for over 100 years. Self-driving vehicles change that. A self-driving vehicle that takes the task of driving away from the driver introduces a radical disruption to the allocation of function and responsibility between people and vehicles. Very simplistically, for the person to be a completely passive user, traveling while doing something else, maybe reading or working, the vehicle takes responsibility for all 5 elements: decide, control, sense, inform, and respond. And actually, it would be a lot easier if we could wave a magic wand and overnight switch from a system where all vehicles are manually driven to all vehicles being self-driving. But we can't do that. Not only will the future result in a mix of self-driving and manually driven vehicles sharing the same roads, but we'll also see a gradual increase of a range of different self-driving vehicles introduced on different vehicles at different times. So how do we get from now to the future? Self-driving vehicles, and I saw some great examples of this visiting one of the research labs this morning, uses a range of different and new types of technology. Technologies that include high-resolution cameras, artificial intelligence to perceive and interpret those images, radio waves and laser light to measure distance, and then vehicles themselves being connected to each other and to the infrastructure around them. In the future, we're unlikely to see any more overhead variable message signs giving us information or instruction about the road ahead. All of that information will be transmitted directly to our vehicles. On the screen, you can see something you may have seen before, the Society of Automotive Engineers levels of driving automation. These are quite a helpful descriptive or explanatory tool. In level 3 automation, if an automated driving feature is engaged, you are not driving. But if the feature requests, you must be prepared to take over and drive. Well, that's not deciding, controlling, sensing, informing, or responding. It's requesting. What does that mean? How will people respond to a request? In level 4 automation, you're also not driving. But the difference here is there will no longer be a situation where the automated driving feature requires you to take over from driving at short notice. Instead, we'll know that that automated driving feature will only operate under specific conditions, maybe related to whether you're on a motorway or what the weather conditions are like. And hold on a minute, if I'm not driving, am I still a driver? And if I'm not a driver, what am I? And if I'm not a driver, then who is? In reality, when we introduce automation into a transport system, whether it's a self-driving vehicle or automated support of air traffic control, people and technologies work in partnership with both physical and virtual elements. We don't have a neat and tidy input-output model of communication between the person and the vehicle. We have a complex, cyclical, continuous partnership between the person and the vehicle. So we need to design careful, continuous interaction to ensure we can enable and support a safe, effective, and satisfying system for all. We can talk about this as a joint cognitive system. So how can we design automation to enable an effective partnership between people and technologies? When it comes to level 3 self-driving features, a particular challenge presents itself in the form of takeover. Many studies have been conducted that explore how long it can take for an individual to respond to a takeover request, where the vehicle gives an alert, usually auditory, visual, and even haptic to the driver, that they need to resume control of the driving task. These studies have mainly been conducted in simulators, which are a really important tool for anticipating and learning how people will respond to future technologies. Ericsson and Stanton in 2017 did a review of all of the studies that had looked at takeover time, and they conducted their own study. They found that where participants were completing a secondary task, like I was talking about before, reading or working, the takeover time of the vehicle took between 3 and 21 seconds, and the median time was 6 seconds. Well, let's think about that. How long is 6 seconds? I'm going to show you while watching a video that's taken from a dash cam that shows a driving incident occurring and the driver responding and avoiding the vehicle. And I'll count to 6 while I'm showing it to you. 1, 2, 3, 4, 5, 6. I'll show you that again. So if you saw there was a driver that had to avoid a car that was on the wrong side of the road because it was doing an overtaking maneuver. 1, 2, 3, 4, 5, 6. Now, in this particular example, it's likely that as the training of self-driving algorithms develops, they'll be able to deal with scenarios like this. But at first, it's most likely that self-driving features will only be able to be used on motorways or similar dual carriageways where this type of incident is much less likely to occur. As well as sensing the environment around people in transport, we're also able to start sensing people within the transport systems. This is important. By sensing people, we can change how we alert them to take over control of the vehicle. Or we can realize that an air traffic controller is struggling to cope with the demand that a current situation is presenting to their cognitive resources. These sensing technologies can be used to understand a wide range of tasks and activities in transport. As this video shows, eye tracking can be used as an excellent proxy for visual attention. I'm very grateful to colleagues at the Department for Transport and University College London for sharing this video. The red dot shows where the driver's eyes are looking. It normally works by capturing information through special glasses worn by the driver. But increasingly, technologies are embedded within the vehicle or within a workplace where we can monitor where a person is looking. Now, this isn't a perfect solution. A person could theoretically be present but absent. Their eyes can be on the external scene, but they're not perceiving, comprehending, or projecting. Their situation awareness may be poor. They may be out of the loop. So there needs to be more detailed analysis than just looking at where a person's eyes are if we're to be confident about our understanding of level of engagement with a task, and that's usually what we care about. A technology that's been a personal interest of mine is thermography. Keep an eye on the nose of this person. This technology uses heat-sensitive cameras to look at the relative distribution of temperature on a face. Our work has shown that as workload, demand, increases, the area around the nose tends to get colder. You can see that by the nose getting slightly greener and yellower. This may be due to one of either two different factors: blood flowing away from the nose to the prefrontal cortex, where cognitive processing takes place, or the impact of increased breathing rate cooling the nose area. In this example, the pilot completed a complicated auto-rotation task in a helicopter simulation. As the demand increased, the workload increased, and the temperature on the nose fell. Another example of a sensing technology is electroencephalogram, or EEG. This technique directly monitors electrical signals in the brain. And a long program of work has looked to establish the relationship between those patterns and different emotions. These graphs show an example that's currently being used by colleagues at UCL and the Department for Transport, looking at traveller engagement. They show measures from EEG using the same time frame where participants are experiencing for the first time a self-driving shuttle. During the scenario you can see here, the shuttle starts to turn right. The engagement increases as participants start, first of all, to be chatting with each other. Then it goes down a little bit as they wait for the shuttle to move. And then engagement spikes as the vehicle starts to turn right, before returning to a lower level after the turn's completed. This method can also be used to help understand stress. Stress generally went up as the vehicle turned and went down after the turn was completed. Now, this type of monitoring is really helpful in understanding how we might design communication and information about future transport technologies, and also so that we can help people be prepared for their own emotional response. The technologies aren't a panacea, but they do help to build up the rich picture of automation in transport. There are very significant individual differences in how these technologies work, though. Some of the technologies are less valid, with different skin colours, for example. In my own case, I've got poor circulation, so my poor little nose always looks cold, no matter how hard I work. The main thing, though, is that actually these methods have good relative validity. So they're really helpful in comparing the responses from the same people for different types of designs and solutions. And we know that as people use technologies, their views change. Siddhartha Katskir and colleagues from Warwick Manufacturing Group highlighted the impact of experience with using a system on driver response. They found that experience of using the automation technology increased the driver's trust. This also shows that experience has an important impact on driver attitude and has implications for all sorts of transport technologies. As well as those within the vehicle, we also need to think about how people around will respond to self-driving vehicle technologies. Neville Stanton and colleagues designed a study that showed video clips of vehicles in front of another vehicle. And while you were watching the video, viewers were asked to judge whether they thought the vehicle in front was being driven by a person or by self-driving software. The results were stark in their lack of direction. When autopilot was driving the car, 50% thought it was autopilot and 50% didn't. When a human was driving a car, 50% thought it was human and 50% didn't. A really intriguing experimental design conducted on Stanford University campus in the US used a setup where the driver of the vehicle was concealed within a specially designed seat, as shown with permission in this image here. It then drove around, and participants were asked their responses. And most people did think the vehicle was self-driving. They adapted quickly, showing trust in the vehicle. They were prepared to cross the road in front of what they believed was a self-driving vehicle. They observed cues from the car's behavior. They looked at how it moved, how it sped up or slowed down, rather than using any explicit external signal or indicator. These results show it's not straightforward to assume that we need design features to replace that human-to-human interaction we currently see between pedestrians and drivers when you catch the driver's eye and make sure it's safe to cross. And more work's currently taking place to look at this matter further. Now, one tool we have in our toolbox as a human factors specialist is the use of cues to influence people's response. A great example of this was found in a trial conducted by Natasha Meratz and her team at the University of Leeds in conjunction with European colleagues. This trial involved 3 different European cities where autonomous shuttles were demonstrated, either with or without clear road markings that showed the planned path of the vehicle. What was most striking here was not only that participants overall felt more safe when there were road markings, but the results were different in different cities. This shows that one design solution doesn't necessarily fit all. We need to be sensitive to social and cultural responses that may be present in different places. So I've given you some examples of automation in self-driving, but there are other settings where we need to think about automation and the role of human factors. Several years ago now, we looked at the impact of automation technology in railway signallers in the UK. First of all, we looked at the distribution between different types of activities for different types of automation. We used self-report methods to ask operators to report their own perceived experience of workload, and we observed their activities in quite a detailed way. And we looked at the relationship between the two. First of all, we found that the highest level of automation, ARS, automated route setting, showed a decreased requirement for the monitoring in the task. This shows the presence of automation led to more spare capacity for operators. You can see that in the green block on the right-hand bar of the graph, quiet time. And we'd expect that. That's automation doing its job. But we found overall, for all types of technology, there was a strong correlation between self-reported levels of workload in the top graph on the right and what we called active monitoring. You can see that by the light green bar on the bottom graph on the right. We observed active monitoring by looking at when operators were leaning forward, actively engaging with the display, as opposed to passively observing and letting it happen. This tells us not only that we can use these methods to understand how automation changes the demands placed on operators, but we can also think about the impact of that support and give guidance about how we get people and technology to work together. But we need to be careful. We looked at a number of different signallers. The graph in the top shows a signaller where there was a really strong, consistent pattern between their own reported level of workload and the observed activities that they were doing. Great. But the bottom right, someone who was doing their task perfectly well, we see no statistical relationship between what was reported and what was observed. We need to recognize that when we introduce new technologies into a system, diversity is going to remain. So I've talked about human-centered approach to automation. I'm going to talk quickly about two other aspects, decarbonisation and end-to-end journey. So why do we need to consider people when we're decarbonising transport? Analysis from 2019, outlined in the Department for Transport's decarbonisation plan, shows that 28% of UK domestic carbon emissions are from transport. And when we consider the implication of capital and operational carbon associated with the construction, operation and maintenance of transport infrastructure, we find an additional 13% of total carbon emissions. So how can a human-centered approach help with our challenge to decarbonise? As we move to decarbonise our transport systems, we are asking people to change. Theories of human behaviour, such as the theory of planned behaviour or the COM-B model of behaviour change, help us to understand what influences people's choices and attitudes. And these theories recognise that individuals are influenced both by long-term attitudes and opinions, but also short-term information or opportunities to execute behaviours. The difference between this short-term immediate thinking and the longer-term engaged processing is shown here, the difference between type 1 and type 2 processing. Very often, if we're to create sustainable change, we need to consider both of these types of processing, the type 1, the immediate, and the type 2, the long-term thinking. So, decarbonising transport feels like it's a technical problem, really, doesn't it? Well, No, we're asking people to change the way they travel and think about why they travel, when they travel, and how they travel. A major example of this is in the UK, the requirement to switch to electric vehicles. We've mandated that the sale of new petrol and diesel cars will end in 2030, and that all new vehicles will be zero emission at the tailpipe by 2035. And then we're also seeing emergent concepts such as the notion of the 15-minute city, where everything we need to live our lives is within 15 minutes walk, or low-traffic neighbourhoods. In the Department of Transport, there's an excellent social research team, and they've been tracking people's attitudes over a period of time, using the same questions repeatedly to track the way that different views have changed. These data show, for example, that an appreciation of the environmental benefits of electric vehicles, one of those extrinsic motivators for behaviour change, has increased from 65% in December 2017 to 81% in December 2021. But we can also see some barriers from this data. In 2017, only 2% of respondents said that electric vehicle charging is easier or more convenient than for petrol or diesel vehicles. This increased to 16% by December 2021, but that figure is still low. And we can see that between 2017 and 2021, the perception that there are not enough charging points increased from 30% to 73%. These type of data tell us we need to consider the human response and motivation in the system. They help to direct policy focus, for example, on improving charging infrastructure and continually improving the capacity of electric vehicle batteries. As we decarbonise, we may also be asking the public to consider the use of new types of technology, such as the increased use of hydrogen in our transport systems. We know there may be a role for hydrogen fuel cells, particularly in maritime, trains, and heavy goods vehicle settings. In the UK, a programme called Fly Zero has also identified a pathway towards future hydrogen combustion passenger aircraft by 2050. Colleagues in a collaboration in the UK who are looking at future energy conducted a survey looking at public perceptions of low-carbon hydrogen. And they identified that whilst people appreciated the benefits of hydrogen, using words like renewable, they also used words like dangerous, safety, flammable, risky. What this shows us is the importance of regular communication and transparency, as well as the provision of data around supporting infrastructure for new users that we're asking to change their approaches. But we also learned earlier, when I was talking about automated vehicles, that as people experience new technologies, their attitudes change, they evolve. They build new mental models of how technologies work. They make changes to the way they trust technology. They adapt their understanding of social norms. We can apply our learning from human response to automation to human-centred decarbonisation. A further way we can look at decarbonisation is through improving the efficiency of construction operations. A programme that's been led by the UK National Highways Organisation has explored the impact of introducing connected and autonomous plant to work in partnership with people in a construction setting. These autonomous electric vehicles reduce the carbon emissions during construction. They increase the efficiency of operations, reducing reliance on diesel construction vehicles. But they also present a really interesting challenge. Sometimes people and technologies use different information from their environment to inform their situation awareness. In this case, look at the image in the top right. We asked a machine to read that information. And whilst that looks to us like a series of curved lines, it didn't to the machine. The machine struggled to interpret non-continuous lines. Now, we don't pay attention to it, but humans are brilliant at interpreting non-continuous lines. Gestalt theory told us that years ago. We see this challenge, this difference between designing for people and technologies in other settings. Say, factory warehouses. We used to design for human comfort. Maybe we should now design for the most effective temperature to enable effective robotic operation. A final example of why we need to think about people when we're decarbonising is through the creation of a strong and innovative organisational culture. A brilliant example of this is found in a project that's of bigger scale than any transport infrastructure project to date in the UK, the building of the high-speed railway HS2. This project will require an equivalent amount of concrete to the amount that would be needed to cover an area the size of Manchester in the UK, 115 square kilometres. Wikipedia tells me that's a similar size in land area to Göttingen in Lower Saxony. So any technologies that reduce the requirements for concrete can have a significant positive impact on embedded carbon emissions during construction, and construction efficiency. An example of this is shown here. When concrete is not of good enough quality, it's measured through a test that looks at specific gravity. It's called a slump test. Now, in normal operations, when a slump test is failed, that batch of concrete and any batch mixed in the same way has to be wasted. The organisation Cloud Cycle developed a new sensing approach that changed the way the slump test was conducted. But critically, it used the data from those sensors to very quickly disseminate the information from the slump test. So using cloud computing and communications, the message was sent back to the production facility much more quickly, and the amount of concrete wasted was reduced significantly. It's estimated that this innovation alone, just a very simple sensor technology, could cut the amount of concrete used on phase 1 of high-speed 2 construction by 420,000 tonnes, an associated carbon dioxide saving of 50,000 tonnes. So the final topic I want to talk about is the human-centred end-to-end journey. This is really taking us back to that heart of systems thinking and ergonomics and human factors. I talked before about the power of cues and affordances. We use these as explicit labels, such as you see with the yellow line at the edge of the platform there, or suggested or implied interaction. Now, this is an example that isn't designed, but someone has noticed that the metal rail affords the act of sitting. But an affordance can be really, really helpful if we want to support an end-to-end journey. So how can we use them? Well, first of all, we can take a lot from understanding how people travel now. And architects have been doing this for years. Take a look at this image. This is something that you may have seen before. In the top left, it's something called a desire line, an imprint in the landscape that tells us that designers got it a bit wrong. They didn't correctly anticipate the preferences or behaviours of travellers. And so those travellers have left a physical imprint or a desire line in the ground. In the bottom left, you can just see an image from the University of Nottingham. And if you just see in the bottom left of that image, there's a bit of a diagonal line. Well, that's the students' desire line. The students didn't like the paths that have been placed, and they chose their own route to get to the main university building. What's really great here is the enlightened estates team at the university did the right thing. And now the up-to-date Google map on the right shows the path that's been built that reflects the desire line. So how can we take that physical approach into the digital? This image is some work that I'd really commend to you, actually, by someone called Erica Fisher. She uses open source data to understand how people travel. This is a map of Berlin. And the blue images in the top right show where photos have been taken by local residents. The red show where photos have been taken by tourists. By using this approach, we can understand where and how people travel. We can think about the different way we provide information to tourists and the different way we provide information to local residents. But we also know and have heard that people are diverse. A tool that we can use to build an understanding of diversity into the end-to-end journey is something called a persona. A persona is an imaginary person used to describe the diverse needs of different population groups. And the data about that persona is based on real data aggregated from a range of different sources. As people, our natural tendency is to design for ourselves, or perhaps for our family members or our friends. Personas cause us to think differently. And sometimes we need to manage contradictions between the needs of different user groups. An obvious example is the need to design a ramp to give wheelchair access, but make sure it doesn't become a trip hazard for those who are not using a wheelchair. We can also use mobile phone data to inform transport design decisions. And that might work really well to design for those who are already travelling. But we need to make sure we don't build bias into our interpretation. If we only use data from those already travelling, we may not be designing for the needs of those who travel differently or don't have mobile phone data that's shared. When we look at people's decision-making about whole journeys, the end-to-end journey, we sometimes struggle to consider a journey as a whole. A really good example of diversity and whole journey choice is found in the book that I'd really recommend, Transport for Humans, by Pete Dyson and Rory Sutherland. This data shows the percentage of people who chose 4 different routes on the London Underground to get from Liverpool Street to Victoria. What they found was that 44% of people chose the route that perhaps looks more geographically direct. In fact, the route on the yellow using the circle line, which looks a bit more convoluted, takes exactly the same time as the one in the top left and is probably more convenient because you don't need to change trains. So using data to understand and demonstrate diversity is really important to challenge the way we design information for traveller choice. But despite my heritage from Nottingham, I am not a Luddite. I firmly believe it's our responsibility to engage with the future of mobility with our eyes open, to embrace the opportunity presented by technologies around us. Examples of that, how we can encourage and embrace innovation, comes from making data from transport systems open. Through doing that in London, many entrepreneurs have now developed applications like City Mapper that help people to choose an end-to-end journey. And we can challenge the way we think about the future and challenge the way that scientists and policymakers think about the future. For example, we can use futures methodologies to think of a scenario where technology is deregulated or one where environmental conditions can trump all. So, what are our priorities for the future? What is a human-centred future of mobility? I've only scratched the surface when I've thought of all of the sources of evidence or all of the examples I could talk about to you today. But there are a few things that we can take forward and use as a basis for ensuring we take a human-centred approach. There will always be limitations on human cognitive capability, but remember, humans are brilliant too. Technologies will continually learn and improve their ability, particularly when they're needing to respond to unusual situations. So we need to consider how and when technologies replace people in transport systems and how to ensure that people remain in the loop so they're able to take an active part in transport and travel decision-making. We're going to continue to improve the way we can sense people in our transport system. Sensing people can help us to understand cognitive states of the user or their behavioural choice, and it may present ethical challenges as well. People are different, socially, cognitively, physically. They'll vary in the way they respond and behave, and technologies need to accommodate those differences. We can influence those responses through demonstration and experience, and through design of vehicles, information, interfaces, infrastructure, and systems. But finally, what is absolutely key to remember is that this is a partnership between people and technologies, between technologies and their infrastructure, between scientists of different disciplines, between international societies, groups, and cultures, between academia, industry, and government. We should remain excited by transport technologies, but continue to recognise the role of people. Thank you.
So, thank you. Thank you, Sarah Sharples, for this very great and inspiring lecture. Thank you for that. So let's have a seat and listen to the audience and listen what questions appear. Before we do that, I have one question for you. So you're a professor of human factors, and at the same time, you're also the chief scientific advisor of the British Department of Transportation.
Yeah.
And this is something we don't know in Germany, actually. And we're very curious to hear and listen what this role is about. So what are you doing exactly in this role?
So being Chief Scientific Advisor is a fantastic role. So I've been a professor in human factors for 10 years, an academic for many years before that. And the role of Chief Scientific Advisor is to provide independent challenge to a government department. So I always talk about it that I speak with the department, I don't speak for the department, and it would be impolite to speak to the department. But my job is both to make sure that the department is using a strong base of science and evidence in its decisions and its policy making, but also to help the Department. The Department for Transport funds a number of research programs in the UK, and one of my jobs is to advise and to lead in the delivery of those programs.
Great, thank you. So I would say let's open up the stage. Any questions from the audience? Please raise your hand. Any question? Yeah, over there, it's at the side. Please, if you like, stand up so we can get the microphone to you. Yeah.
First of all, thank you for that amazing lecture. You started out with mostly examples from car-centric, kind of individual person transportation, and then later went on to public transport, all the other stuff. And I was wondering, because you're from the UK, we have a similarly strong kind of public transport culture here in Germany. But a lot of psychological or human research, of human factors research comes from America, where we have, where they have a more car-centric, I would say, transportation culture. What do you see in like an international global context as one of the, or some of the challenges maybe that we're facing as, let's say, European scientists trying to represent like a more carbon-friendly outlook on, you know, revolutionizing transportation? Or is there even a challenge, or are we all kind of pulling the same strings anyway?
I think that's a really great question, actually. And it's interesting that I've really seen the UK and European colleagues take a real lead in a lot of the human factors, self-driving research. I was just thinking, I think all but one of the examples I showed was from either UK or European-based work. And that's not a coincidence, because there have been a large number of collaborative consortia that have really focused on self-driving studies and technologies. But I think you're absolutely right to highlight that we need to work collaboratively and internationally on these challenges, because These are extremely difficult changes that we're looking at, and we need to have as much transferable learning as we can between different settings. What is really interesting, though, as I pointed out, was that cultural attitudes and acceptance of technologies can be very different in different settings. And so we just need to get this balance between collaborating and getting consistency where we can, but also recognizing that the way in which we implement technologies may well be quite different. There's another area, though, which is the decarbonisation part of the portfolio. The amount of funding that the US government is able to put into decarbonisation technology, quite frankly, dwarfs anything we're able to do, even collectively from a Europe point of view. So it's also really, really important that we learn and then we critically challenge the transferability of that learning. As an example, if we're looking at electrification of vehicles, it's going to be much more viable to have comprehensive coverage of charge points in a country like the UK or Germany than it ever would in the US. So those differences are there, and of course that's the reason why we have such different investments in public transport in the UK and in Europe compared to the US. But I will say that public transport, one of the best ways we can decarbonise transport is by having people use public transport more, because then they're using shared mobility to the maximum capacity and not actually resulting in any additional emissions. So that's something we need to be really, really careful to consider, but it's a really good question.
Yeah, I agree. Thank you for your question. Another question from the audience. Please raise your hand so it's easier for us. Yeah, over there.
Thanks a lot for this very interesting talk. My question as a neuroscientist with a human factors background is what are the challenges or what are the questions you would like us to answer? Like, are there like specific points where you say like, oh, there's where neuroscience could really contribute?
That's brilliant that you've got that background. When I did my psychology degree, neuroscience was only really just emerging as a discipline from a sort of a comprehensive measurement point of view using technologies like MRI. And so it's fantastic what's happened. I think what we really need is a match between the things we can measure from a neuroscience point of view, some of the examples I gave, such as EEG, or other measurements such as functional near-infrared spectroscopy or MRI. And the cognitive concepts, all too often, I actually see people making too much of a leap between the physiological and the real world. And the problem is that doesn't necessarily also capture the wider setting. So actually, we need more people like you, because if you've got a human factors background, you understand that system's context, but you're also working in that deep scientific method that we need to increase in its validity, its reliability, and also its portability. The other thing is we need to have a really holistic education of people dealing with technologies like this, because I didn't have time to talk about it today, but the ethical and privacy implications of all of this data are really important for us to consider. And we mustn't be naive in thinking that technology is just going to solve everything and we'll be able to monitor everything, because we need to understand and respect the individual nature of that data as well. So I think having that holistic outlook is really important.
Great. Thank you. So let's also see if we have questions from outside the lecture room. We know that we have probably some questions from Twitter, so I'm just looking to the social media team if there are questions which are coming from Twitter.
Yeah, thanks, Sarah. We've got one question from the Fridays for Future Technische Universität Twitter account. They ask, a human-centered future of mobility would ideally exist without injuries and over 1 million road deaths per year globally. How can we reach Vision Zero as quickly and effectively as possible?
It's a really, really good question, and obviously one of the main motivators for investment in self-driving technologies is to improve safety on our roads, and you're absolutely right that it's remarkable, actually, the level of road injuries and serious accidents that we see. I think that what we need to do is we need to get the regulation and the policy right to enable us to very carefully introduce this technology so that we are continually and openly learning. One of the things I was really impressed to see in my visit this morning was the sort of test environment that's been developed here in Berlin to enable the development and understanding of automated vehicles in a real-world setting, and not just a real-world setting, but a really busy, dense setting, such as one of the main thoroughfares in Berlin. That's exactly the sort of work we should be doing, because we need to recognize that technology, it's not going to be perfect, and there will be incidents and accidents that happen as we introduce these technologies. But we need to learn from them, we need to be honest, we need to have good data sharing agreements to make sure that when any trials are done, we're able to analyze and fully understand any incidents or accidents that happen. And we need to take a whole systems perspective. We need to really be careful that as we introduce this technology, we are making our roads safer. That may mean that we're changing the nature of incidents, but overall it has to be safer, otherwise it's not appropriate to introduce these new technologies.
Great, thank you for your answer on this question. Maybe I just switch to the other side, because we now choose two on that side. Is there a question on this side? Yeah, right here, third row. Maybe you can just stand up and then, yeah, exactly.
Yes, hi, thank you. I'm from the human factors department here, and I'm interested in human factors in shipping. And you showed a ship all the time on your slides, but you didn't tell us anything about ships. So compared to automation in cars, what do you think is the biggest challenge for automation in ships? Because 6 seconds is no problem.
It's, no, I feel terrible now that I didn't talk about maritime enough. So please do rest assured I do lots of talks and work very closely with our maritime team in the department. So maritime's a really interesting area, and I sometimes joke that living in Nottingham, it's right in the middle of the UK. It's as far from the sea as you can get. So I hadn't had much encounter with maritime research before I joined the Department for Transport. I think one of the first challenges is maritime is an international sector. And so actually, anything we do, we tend to be quite parochial when we do research. We think about, and it was your question earlier, we think about our own cultures and our own settings. We can't do that with maritime. We have to work internationally and think about the culture and the way of working that is happening in all seafaring settings. There are a number of things. We urgently need to decarbonise maritime. The emissions from maritime are not as high as for personal automotive vehicles, but they're, I think, from memory, around 18%. So they're still really quite high, and it's known as a hard to decarbonise part of the sector. So there are two things we need to do. First of all, we need to reduce the emissions from the vehicles that we have now. Because the thing that's interesting about maritime is vessels last for 25, 30, 40 years. So vessels we have on the seas now will still be here in 2050 when we need to be reaching net zero. So we need to be thinking about how we can have a human-centered approach to the decarbonisation of current vessels, which often is around the way in which they're piloted and therefore minimising the emissions during current use. We're then also looking at future technologies and the replacement of carbon-emitting fuels. But as a human factors person, you will know, and I'm very aware of, the quality and comfort of seafaring is something that has been a concern for many, many years. And there have been a number of incidences in the last few years that have really brought this into stark focus. we've had a great example today. We discovered when we met before the talk, all four of us who have mentioned that we're women in traditionally male-dominated roles are the first women to take on those roles. The representation of women in maritime is shocking. And what that means is we're missing out on 50% of the population in completing those tasks, and we're not giving access to roles for women in all parts of the maritime sector. So actually thinking about the quality of the experience of working in the maritime industry and how we can diversify those who engage with the maritime industry is also something I would say is tremendously important.
Great question, thank you. So Sarah, time flies, and the Q&A unfortunately is already over. We thank all of you for your questions, and thank you, Sarah, for the answers.
Thank you.
So, Sarah, give her an applause. Thank you.
Thank you. Want me to come down or stay here?
I'm going down.
Do I stay?
Stand up.
Okay.
Sorry, no micro. So thank you very much, Sarah, for this wonderful talk, for your wonderful time that you spent with us. And for me, I now have the honor to thank you. And I see that we have other guests here, so welcome you all. Does anyone of you want to come to the microphone? Yes, please. Then, please.
Thank you for your lecture, Professor. We are End Fossil Occupy Berlin, and we want climate justice and the end of the fossil fuel industry. COP27 started yesterday, and we, together with End Fossil groups around the world, ask once again, why keep talking when we could start acting? The fossil fuel industry is largely responsible for climate change. Only through its dismantling, a climate-friendly and social future is possible. We demand that the public transport be made available for everyone through the reintroduction of the €9 ticket, and eventually through free public transport for everyone. The expansion of the public transport system and the extension and the improvement of bicycle paths all over Berlin. The best electric car is a bicycle. We demand that universities in Berlin, including the TU Berlin, stop taking money from fossil fuel industries such as BMW and Volkswagen. Thank you for your attention.
So, thank you very much for your important work and for your contributions. Thank you for being here. I hope you will be our guests later on in the Lichthof. You can leave your transparent here or wherever we can see it. And I also hope it will be on the photographs. So still, of course, I also have to thank Sarah for her wonderful talk. And it's me to hand over the certificate. So this is our official certificate for the Queen's Lectures. Thank you so much for being with us. Thank you so much for attracting so many people. And hope we will have a wonderful evening discussing these important topics. And of course, we also have some presents.
Oh, thank
so
you.
I hope you remember Berlin and the Technische Universität in warm heart.
Thank you.
You are our guests whenever you want. And
you.
now I invite you all to come to our famous Lichthof and to have a conversation with us. So please, very pleased to see you later, and just come to the Lichthof right now.
Thank you. Thank you so much.